So hopefully this is recording. And hopefully nobody comes in late to disturb us. Alright, page 45. You had number 2, 4, 6, and 10.
8.
2, 4, 6, 8, and 10. Picky, picky, picky. Let me go ahead and check those, and then we'll get to the answer. Pretty good stuff, huh? No? Who said that? George? No. And if you weren't here Friday, then I need to see page 36 as well.
Which one was to do 2 through 8? Yeah, no, I'm not. I forgot what I was doing.
Imagine that.
What's the date today?
Today's the 14th. Yeah, page 36.
This Friday, I gotta work start off with page 36. Yesterday, I was Friday.
Find it, Sarah?
No, I don't know where it is. I'll have to get it. So, Mr. Mackey, I do have a question.
Yes.
Okay, so, when you're doing the absolute, so for example, let me think of one. So 7, or let's just say an example, but 7 is less than 6. Would you switch the sign, Z is greater than -6?
Yep.
But if it was a negative, would you switch it when it's a positive?
Mm-hmm.
Okay.
Actually, we're going to talk about that because if you read, then you came across this right here. Absolute value of x, if it's less than -5, there are no solutions. It's the empty set. Absolute value of x greater than -5, infinite solutions, which means it's all real numbers. So on number 6, numbers that are greater than or equal to -1. Number 8, numbers that are less than or equal to -4. One of those is going to be all real numbers. The other one is going to be no solution. Which one would that be? I know what you did on your paper. For number 6 on your paper, you would have had Q greater than or equal to negative 1 and Q less than or equal to positive 1. And so you would have went negative 1, positive 1, greater than or equal to, less than, you would have done it like this. This, incorrect, number 6.
Okay, the thing that I get from the number 6 is only one number. So how would you take that out?
I just showed you. Drop the absolute value signs and write it exactly the way that it looks without the absolute value signs, symbols. And then write it the same way again, except flip this around and change the signs that way.
So you would, if it's absolute value, you would change it from whatever negative positive to negative positive. That's only for absolute value, right?
Mm-hmm. So, this won't work. So number 6, would that mean then that it's all real numbers or the empty set? Look back at that example. What do you think, Abby? Empty set? If it's greater than the negative number, infinite solutions. So for number 6, the answer would be all real numbers. It would be the entire number line. Number 8 says less than negative 4. Now here's the thing. Can an absolute value ever return a negative?
Hello?
Is the absolute value of any number negative?
No.
No. This cannot be. So the answer to number 8 is the empty set. There are no solutions. What? Alright, this is new. We haven't done this before. I'm not expecting perfection. All I'm expecting is, hey, here this is, here's how you do it, here's where it won't work. I'm looking at the answers now. Alright, so number 2 is right here. This is what your graph for number 2 should look like. Number 4, right next to it. Even though this doesn't say on number 2, even though it doesn't say and, this is an and. Number 4 very specifically says or. This is an or. And or. Number 6, all real numbers. Number 8, the empty set. And then number 10. Would this be an and or an or? An and.
what number?
10.
That's what I confused on is like how to make like how to recognize if it's gonna be an or.
Yeah. If it's going to be an or, it will specifically say or. Or.
Okay, just get on the
The absolute values, sometimes there'll be an and sometimes there'll be an or. This is an and. This is an and. Or. Let's see here. Yeah. Some of these will be and, some of them will be or. So what do we gain out of this section, besides just being able to plot on a one-dimensional number line? We find out again that working with absolute values means that you're going to set up two situations. Just like when we were solving absolute value equations, this gave us two different equations or inequalities to solve. Then we learned about and or, unions or intersections. When you combine the both, that's an and. When you take what you have in common, it's an or an intersection. Alright, we're going to skip ahead. The first two chapters are really just review of Algebra 1. I'm just going into it just a little bit deeper. We're going to skip all the way over to page 69.
Oh no, not you.
Alright, in Algebra 1 we learned about linear relations or linear functions. Whatever the relation or function is, if you were to graph it, it would make a line. That's why they call it linear. The first part of that word spells line, linear. Typically, you have a linear equation if the highest exponent in the entire equation is positive 1. There are also nonlinear equations or nonlinear relations. Any relation or function that you can graph that has a bend, a corner, some sort of break, it's no longer linear. Lines are always straight, and that's why it's redundant to use the phrase straight line. If in any way it's not straight, it's not a line, therefore it's nonlinear. Some examples of relations that will give us a line are 4x minus 5y equals 16. Even though we have x's and y's, the greatest exponent for any term is 1. X equals 10. That's linear. What sort of line would x equals 10 make? Don't say straight.
Up and down?
Yeah, vertical. Vertically vertical, up and down. Y equals, if that's all you have, perfectly horizontal. X equals perfectly up and down. Y equals negative 2/3 x minus 1, linear. Y equals 1/2 x, linear. Now here's what you can notice about the way these are set up. The powers, of course, there's no power greater than 1. No exponent greater than 1. But also, the x is not the part of a denominator, and it's not under a radical. It's out there free to be moved. Now look over here at the next column, nonlinear equation. What makes the first one nonlinear? Well, it's this power of 2 here with the y. Anytime anything in the equation, any variable in the equation has a power greater than 1, it's all of a sudden now not linear. It's not going to make a line. Same with example number 2. This is x to the 1/2 power. This has a power less than 1. That means it's not going to make a line. Square root means power 1/2. Alright, so in your calculator, turn your calculator on. Here's square root in blue right above the x squared button. So do square root 25, enter.
I forgot to do that. Oh wait.
The blue and then X2.
Yes. So what did you get?
5.
5. Alright, now we're going to do the same thing, only this time we're going to use an exponent. So this time you're going to do 25, and then the rooftop, caret key, right above the divide sign. 1 divided by 2. Let's say 5. So a radical to the second power. A square root is really 1/2 power. So everything in this equation does not have an exponent of 1. The x has an exponent of 1/2. X plus x times y equals negative 5 over 8. This one would not be a linear equation because at some point we're going to have to divide by x to get it away from the y. And when we divide by x, that means that the x is going to end up in a denominator. Therefore, it's not going to be linear. In the next example, the x is very clearly in the denominator. If you were to graph that, it's quite clearly not linear. So identifying linear functions. State whether each function is a linear function, write yes or no, and explain. A. F of x equals 8 minus 3/4 x. Now could you move everything away from the x through mathematic operations and it be all by itself without a fraction? The answer is yes. It's kind of free floating there. So this is a linear equation. B. F of x equals 2 divided by x. You can't do anything with this x except multiply it to the y. and in that case it's not by itself, or divide the 2 by it, and in that case it's on the bottom of the fraction in the denominator. So no, this is not a linear equation. G of x, y. No, the two variables are multiplied together. There's no way that you could get y equals or just x equals. How about 1a? Yes or no? Linear or not linear? It's not linear. X is in the denominator. How about 1b? Yes. Evaluate a linear function. Despite all the reading that we have to do in these cases, here's what happens. They give us a function and they tell us the number to put into x. That's evaluating a linear function. The growth rate of a sample of Bermuda grass is given by the function f of x equals 5.9x plus 3.25, where f of x is the total height in inches, x days after an initial measurement. How tall is the sample after 3 days? You just simply take the x out, replace it with the 3, work it out and get an answer. Now, in these problems, you do have to pay attention to the descriptions of each variable. F of x is just another way to write y. Y is the total height in inches. X, the number of days. So if instead they said after 20 days, if the grass is 20 inches tall, how many days? Well, that kind of flips things around. So here's our function. F of x equals 5.9x plus 3.25. This right here is no more than y. You can take the f of x out and just put the letter y there. But what this side of the equation stands for is height of grass.
Wait, what's that for?
What? I'm explaining how you work it differently based on the information they give you. X, number of days. So one of two things can happen. They can either say after 10 days. Well, they just told you how much the number of days is. So you replace the x with 10 and you get 5.9 times 10 plus 3.25. This is 59 plus 3.25. That equals 62.25. Or, instead of giving you the number of days, they can tell you how tall the grass is. If they say the grass is 20 inches tall, then here's how you would work it. 20 equals 5.9x plus 3.25. And now we use our 3 steps to solve this. Move all the x's to the same side. It's already done. Move everything else to the other side. This is plus 3.25. So minus 3.25 minus 3.25, 16.75 equals 5.9x.
This is
Now divide both sides by the number in front of x. It took about 2.8 days for the grass to get that tall. So y equals 2.8. About.
Wouldn't it be x equals 2.8?
You're right, x. Like the number of days, yes. About 2.8. Now the reason why I'm showing this to you is in evaluating functions, either they give you the input value. In this one, I said, okay, 10 days. You take the x out, put the 10 in its place, you work it out. But they can also come along and say, well, here's the answer. Now, how many days did it take to get this answer? And that's what we did right here. The grass is 20 inches high, so how many days did it take for it to grow to be 20 inches? In that case, we substituted 20 for the y, we solved for x. Which Tristan was so graciously able to point out. X. So in the example that they did, how tall is the sample after 3 days? So take the x out, put the 3 in, work it out, boom. The height of the sample after 3 days is 20.95 inches. But down here in the guided practice, if the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? Figure that out for me. How many days is 50.45 inches tall? Go ahead.
What?
If the Bermuda grass is 50.45 inches tall, how many days has it been since it was last cut? What did you get? You ate the grass? What's the matter with you people?
Hey, I ate grass before.
It's been 8 days since its last cut.
I mean, I'm going to use your body rather than that. And that's fast.
Linear equations are pretty simple when they're in slope-intercept form. That's what we just got through looking at. And that function, what was the slope? Here it is, f of x equals 5.9x plus 3.25. What's the slope? 5.9. Slope. So this is the intercept. What does that mean? Okay. That y-axis, the y-intercept. This is also the number that we call the beginning. Obviously, when they cut the grass, they cut it 3 1/4 inches tall. So the grass is never going to be shorter than that. It will always start out being 3 1/4 inches tall, and it will get bigger by this amount of taller. But instead of slope-intercept form, sometimes we have things in standard form. That's where the x and the y are both on the same side of the equal sign. Alright, so this is very important. The standard form of a linear equation is ax plus by equals c. A just stands for some number, B stands for a number, C stands for a number. Where A, B, and C are integers. Not fractions, integers. Not decimals, integers. With the greatest common factor of 1. That means you can't divide out a number out of all 3. It's completely reduced. And A and B are not both 0. Here's an equation in standard form. The x and the y, they're both on the same side of the equal sign. A is 3, it's the number in front of x. B is 5, that's the number in front of y. And C is 12, that's the constant that doesn't have a variable with it. Writing equations in standard form. This is not even in slope-intercept form. But here's an equation that has x on one side, y on the other side. It's not in standard form, so we need to change it to standard form. The very first thing they do is move the y term over with the x's. So now we have negative 3/10 x minus 8y equals negative 15. We would be done except that there's a fraction in front of the x. They all have to be integers. A, B, and C are integers. Negative 15 is an integer, negative 8 is an integer, but 3/10 is not an integer. To get rid of this fraction, multiply everything by 10. Well, they multiplied it by negative 10, which took away the negative. That made that positive 3, positive 80, positive 150. Alright, so we're going to start it this way. Your work will be on page 71. And it's just going to be 2 through 10, the evens. State whether each function is a linear function. Write yes or no and explain. The only time you'll have to explain is if the answer is no.
Okay.
71. 2, 4, 6, 8, 10. On 6 through 10, write each equation in standard form. Identify A, B, and C. So you'll have to write out A equals this number, B equals this number, C equals this number. Just like in that example.